Are you excited to dive deeper into JdbcClient? Today's video is going to be super practical. We're going to insert data using JdbcClient, and we'll explore multiple approaches to see what works best in different scenarios. So grab your coffee, open up your IDE, and let's get coding with JdbcClient. As you can see on my screen, we have this employee repository interface. We're going to implement all its methods step by step using JdbcClient. But in today's video, we'll focus on the saveEmployee method. Now if you remember, we've already implemented this using JdbcTemplate and named parameter JdbcTemplate in previous videos. But today, it's all about JdbcClient, and we're going to see multiple ways to implement saveEmployee using this new, cleaner API. Alright. First step, open your parent pom.xml file. Make sure you're using Spring Boot version 3.2 or higher, because JdbcClient is only available from that version onward. As you can see on my screen, I'm using Spring Boot 3.4.4, so we're good to go. Okay, now let's move forward. Create a new class called Employee JdbcClient Repository. This is where we'll implement all our methods related to JdbcClient. It will be similar to how we implemented them using JdbcTemplate and named parameter JdbcTemplate earlier, but this time we'll use the more modern and fluent approach provided by JdbcClient. Alright, next up. Annotate this employee JdbcClient repository class with a repository. Also give the bean a name. Let's name it Employee JdbcClient Repository. Now, let's implement the employee repository interface. Override all the methods. Next, inject the JdbcClient into our repository class. Make sure you're pulling JdbcClient from the correct package. That's org.springframework.jdbc.core.simple. Alright, I know what you're thinking. How do we get our hands on the JdbcClient bean? Don't worry. Spring Boot has got our back. Just like it automatically configures JdbcTemplate and named parameter JdbcTemplate, it does the same for JdbcClient. No need to set up anything manually. Spring Boot will handle all the magic behind the scenes. All we have to do is inject it, and boom, we're ready to roll with a fully configured JdbcClient. It's that simple. In this video, we're going to focus on implementing just the saveEmployee method. But here's the twist, we'll be using different approaches with JdbcClient. By the end of this video, you'll see how flexible and powerful JdbcClient can be when handling NSERT operations. Alright, remember in the last video, we discussed that JdbcClient supports positional parameters just like JdbcTemplate? Well, today we're going to use that feature. First up, we'll insert data using positional parameters. It's as simple as you might expect. We've already written the positional insert query for the employee in our JdbcTemplate class. Let's reuse our existing query. Just copy it from there and paste it. Okay, so now we also need the employee ID. For this, we'll need a key holder object for JdbcClient, just like we used in JdbcTemplate. Now, let's talk about JdbcClient. It provides an SQL method, as you can see on my screen, where we can pass our query directly. This method returns a statement spec object, which then gives us access to multiple methods to bind parameters, set configurations, and execute the query. Okay. Pass our query to the SQL method. See on my screen, JdbcClient provides multiple param methods where we can pass our corresponding values. These values are mapped based on the order of the positional parameters. See on my screen, as you can see, I've highlighted the param method. This one takes an array of values for our positional parameters. We're going to use this first. In this method, we need to pass the values in the same order as our question marks in the SQL query. Okay, let's pass the parameters for our insert query. Our query's first question mark is for employee name, so we pass employee name first. Next, second question mark is for age, we pass age second. Then joining date for the third. And finally, department for the fourth. This ensures that each parameter value corresponds to its designated placeholder in the SQL query. Alright, see on my screen, it provides multiple update methods. There's one that takes a key holder and column names. Another that just takes a key holder. And finally, one that takes nothing. So, if you don't need a generated key back, you can simply use the update method that takes nothing. But here, we want the employee ID back. That means we need to use the update method that takes a key holder. Pass the key holder object as the first parameter, followed by an array of column names. In our case, the column name is just employee ID. This method returns the number of inserted rows. So if the insert is successful, it should return 1. Okay, here's an important detail. The update method takes a varargs parameter for key column names, which means we don't need to create an array. We simply pass our employee ID column name directly. Okay, now let's log the number of rows insert. Okay, now let's set the employee ID from the key holder. The key holder contains the generated key from our insert, so we can simply retrieve it and set employee ID in employee object. Exactly, it's the same approach as we do in JdbcTemplate. The next step is to return the employee object. Okay, see, it's all completed now. We first pass our query using the SQL method. Then, in the perm method, we pass all our positional parameter values in the exact same order as the placeholders in our SQL query. Next, we call the update method and pass the key holder to capture the generated key. Okay, now let's go ahead and call this new method from our employee JdbcClient repository inside the service layer. Currently, we're using the named parameter JdbcTemplate version, but now we'll switch it to use our JdbcClient-based insert. And hey, just a quick note, if you're not sure how to switch between multiple beans using a qualifier, I've already explained it in detail in my Spring Core playlist. So if that part is new for you or a bit confusing, make sure to check out that video. It'll help you understand how to properly inject the right bean when you have multiple implementations. Start the application now. Okay, now let's switch to Postman. Okay, so I'm going to add a new employee. Rishabh, 32 years old, belongs to the developer department, and his joining date is April 12, 2025. Let me quickly enter the details in the JSON body here in Postman. Now I'll hit send. Alright, see, we got a successful response. That means the employee was added successfully. And look at that, we received employee ID as 44 in the response, so our key generation worked perfectly. Now let me quickly switch to dbeaver and verify that this new record has actually been inserted into the database. See, there it is. Rishabh's record has been inserted perfectly. Employee ID is 44, name is correct, age is 32, joining date is April 12, 2025, and department is developer. That means our entire flow using JdbcClient is working as expected, from inserting the data to getting the generated key and verifying it in the database. As you can see on my screen, in approach 1, we use the param method to pass all positional parameter values in just one method call. This approach is simple and effective when we have a small number of columns. However, the challenge arises when the number of columns increases. If you have many columns to insert, it can become harder to maintain because each column must be passed in the exact order they appear in the query. This makes the code less readable and can lead to mistakes, especially if the number of parameters grows over time. Alright, now let's take a look at another approach. First, let's comment out the current code. Okay, now let's pass our query using the SQL method. As you can see, passing the query through JdbcClient is always the same. There's nothing new here, nothing changes in how we define the query. What we're going to change is the way we handle our parameters. Instead of using the param method, we'll look at a different approach that makes it easier to maintain, especially when dealing with more columns. On my screen, you'll see a method named param, which accepts a value of any type. This method allows us to pass any type of value as a positional parameter. It can accept values like string, integer, and so on. Now, the cool part is we can chain this method, meaning we can call param method multiple times. So, if our query has multiple question marks, we'll pass each value one by one using these chained param method calls. But here's the important thing: when we chain param method, we need to pass the values in the exact same order as the question marks in the query. So, the first param method call corresponds to the first question mark in the query, the second param method call corresponds to the second question mark, and so on. This way, JdbcClient treats each param method call in the correct sequence, ensuring that the first call maps to the first placeholder, the second call to the second, and so on. Okay, now let's insert our employee using the param method, and remember, order matters here. So first up, we pass the employee name, because that's our first question mark in the query. Next, we pass the age. Then comes the joining date. And finally, the department. And finally, let's call the update method, just like we did in the first approach. There's no change here at all. We still pass the key holder to capture the generated employee ID, and the column name. In our case, it's just employee ID. See on my screen, we're passing all the parameters using chained param method calls, and here the order really matters. Each value you pass should match the position of the question marks in your SQL query. So the first param method sets the first placeholder, the second sets the second, and so on. This is super important, because if the order is wrong, the data will go to the wrong columns. So just make sure you're always following the exact order defined in your insert query. Alright, let's restart the application again.
Cool, now let's switch to Postman.
Alright, this time I'm going to add a new employee, Sachin, who is 45 years old and belongs to the HR department. Let's hit the API with this data. Great! See, we got a success response, and the new employee ID is 45. That means the insert worked perfectly. Now let's quickly open dbeaver and verify it in the database. See, there it is. Sachin's record has been inserted with all the correct details.
Awesome.
Alright, so let's quickly talk about this. In the previous approach, remember we used the param method to pass all our positional parameters. Now here's the catch: when you're using this method chaining style, order is everything. You've got to make sure that the order in which you call param method matches exactly with the position of question marks in your SQL query. Because guess what? If you accidentally pass age where name is expected, or department before joining date, the query won't complain. But you'll end up with messed up data in your database. And that's even worse than an error, right? So just be super careful with the order. One small slip and the wrong data goes into the wrong column. Now, let's discuss another approach to handle this. First, let's comment out the previous approach's code. Alright, now look at my screen. I've selected a different param method. This one takes two parameters. The first is JDBC index, and the second is the value. So, what's JDBC index? Well, it tells us which question mark we're targeting to pass a value for, just like how we used to do with prepared statement or JdbcTemplate, where we'd call set method to set value and specify the index for each parameter. Now, in the previous approach, we had to carefully maintain the order of the param method calls to match the positional parameters in our query. But with this approach, we can call param method in any order, which is way more flexible. The important thing here is that the JDBC index must point to the right question mark. For example, if it's the first question mark, pass 1 for JDBC index, for the second, pass 2, and so on. This makes it easier to manage, especially when you have many parameters in the query. Okay, now let's set the parameters using the new approach. For the first parameter, which is employee name, we'll pass 1 as the JDBC index, because it's the first question mark in the query. Next, for age, we'll set the JDBC index to 2, since it's the second question mark. For joining date, we'll set the JDBC index to 3. And finally, for department, it'll be 4. As you can see on my screen, you might be thinking, aren't I passing the parameters in the same order as before? Yes, you're right, but here's the cool part. I told you that with this approach, you can actually pass the parameters in any order you want. On the right side of the screen, you'll see the same code, but this time, I've passed the parameters in a different order. However, notice that the JDBC index is still the same as on the left side. This is the beauty of this approach. As long as the JDBC index correctly points to the right question mark, the order in which you call param doesn't matter. So, you can choose whichever method feels more comfortable to you. Both approaches will work exactly the same. Alright, let's restart the application now.
Switch over to Postman.
This time, I'm going to add a new employee, Pankaj, who's 38 years old and belongs to the QA department. Send the request. See, it got success, and we received employee ID 46. Now let's quickly switch to dbeaver to verify it in the database. Alright, see on the screen, the record has been inserted correctly, just as expected. So far, we've explored 3 different approaches using positional parameters with JdbcClient. Now, as we discussed in the last video, JdbcClient also supports named parameters, just like we did with named parameter JdbcTemplate. So, we'll explore multiple ways to use named parameter queries with JdbcClient. These are more readable and easier to maintain, especially when your queries involve a large number of columns. Okay, so earlier in one of our named JdbcTemplate videos, while we were learning named parameters, we had already written this named parameter query inside the employee named JDBC repository class. So let's just copy that same query and paste it here. No need to rewrite, we'll just reuse and see how to work with it using JdbcClient. Alright, let's comment out the previous approach code. Okay, now let's pass our named parameter query using the SQL method of JdbcClient, just like we did earlier with the positional one. The way of passing the query remains the same, no change here. Alright, on my screen you'll see a highlighted method called param_method. This one takes two arguments. The first is the name of the parameter, and the second is its value. Now, this name should exactly match the named parameter we used in our SQL query. Spring will then automatically bind the value to that named parameter, just like we saw earlier with named parameter JdbcTemplate. Alright, now let's pass our parameters.
First up, we have employee name. Next is age. Then joining date. And finally, department.
But here's the cool part. The order in which you pass these parameters doesn't matter. Yup, you can pass them in any order you like, as long as the named parameter names match what we used in the SQL query. So, it's totally flexible. Now, let's call the update method and pass the keyholder, just like we did with the positional parameters. There's absolutely no change here. We're using the same approach, just with named parameters. Okay, as you can see here, we're passing all our named parameters using the param method, and we're chaining them together for cleaner code. But here's a key difference. In named parameter JdbcTemplate, we would typically need to create a map SQL parameter source to map our parameters. But with JdbcClient, we can just pass the values directly using param method in a much more straightforward way. Now, let's go ahead and restart the application.
Now, let's switch over to Postman.
I'm going to add a new employee, Rahul, who's 33 years old and works as a developer. Now let's hit the request. Okay, as you can see, it was a success, and we got the employee ID 47. Now, let's open dbeaver and verify the data.
See that?
We've successfully added Rahul to the database with employee ID 47. Everything looks good. As you saw, in the previous approach, we passed each parameter one by one using the param method. However, in named JdbcTemplate, we have the convenience of passing the entire object using bean property SQL parameter source. This allows Spring to automatically map the object's properties to the SQL query parameters. Now, the question is, can we achieve the same with JdbcClient? Can we pass the entire object without individually specifying each parameter? And the answer is, yes, we absolutely can. Alright, here's an important thing to note when we're using bean property SQL parameter source with named JdbcTemplate. For it to work seamlessly, the named parameters in your SQL query and the fields in your Java object must have the exact same name. Yes, you heard it right. For example, if your SQL query contains :employee name, then your Java object should have a field called employee name to automatically bind that value. It's all about making sure those names match, so Spring can do the magic of mapping them together. Let's dive into how we can do this in JdbcClient. Commenting out the previous code.
Alright.
Now look at my screen. One of the overloaded param source methods is highlighted. This version takes a SQL parameter source object as its argument. That means we can pass either a map SQL parameter source or a bean property SQL parameter source, just like we do in named JdbcTemplate. So in our case, let's use bean property SQL parameter source and simply pass the employee object to its constructor. This will automatically map all the fields from our object to the named parameters in the query, as long as their names match.
Super convenient, right? Cool.
Now let's call the update method, just like we did in the previous approaches. Alright, see on my screen, in this approach, we're keeping it super clean. We pass our insert query using the SQL method, and then directly chain it with the param method. But this time, instead of passing each parameter one by one, we pass a single SQL parameter source object of type bean property SQL parameter source. And this object wraps our employee bean, so Spring will automatically bind the values by matching the named parameters in the query with the field names in the object.
Pretty neat, right?
Alright, now let's restart the application. Switching to Postman now. This time, I'm going to add a new employee, Rohit, 38 years old, and he belongs to the developer department. Let's hit the request and see what we get.
Awesome.
As you can see, the request was successful, and we got employee ID 48. Now, let's quickly switch to dbeaver to verify.
And yup, there it is.
Rohit has been successfully inserted into our employee table. That confirms our final approach using bean property SQL parameter source with JdbcClient is working perfectly. In the previous approach, we passed a SQL parameter source object, specifically a bean property SQL parameter source, into the param method. Now you might be wondering, can we simplify this even more? Like, can we just directly pass our object and let JdbcClient handle the rest behind the scenes? And the answer is, yes, absolutely. JdbcClient is smart enough to inspect the object and automatically convert it into a compatible SQL parameter source internally. So we don't need to manually wrap it ourselves. Alright, let's first comment out the previous approach code. Okay, so on my screen you'll see one method highlighted. It's called param_source. This method is super handy because it accepts our custom object directly. No need to wrap it in a bean property SQL parameter source manually. Spring under the hood will automatically convert it into a SQL parameter source based on the field names in our object. And just like with bean property SQL parameter source, one important thing to remember here is, your named parameters in the SQL query must exactly match the field names of the object you're passing. So for example, if your employee object has fields like employee name, age, joining date, and department, then your SQL should also use the same names. Otherwise, Spring won't be able to bind them correctly. Now, let's pass our employee object directly here. Next, call the update method, just like before. See our code now.
It's much simplified, right?
We've streamlined the process and made it more efficient. Now, I'd love to hear your thoughts. In the comments section, let me know which approach you like the most, whether it's the positional parameter approach, named parameter approach, or the one where we directly pass the object. I'm curious to see which one works best for you. Alright, now let's restart the application. Switching to Postman now. This time, I'm going to add a new employee, Kapil, 48 years old, and from the HR department. Send the request. See, it was successful, and we got employee ID 49. Switches to dbeaver to verify. See it? It's successfully added in the database. Kapil is now in the system with employee ID 49. Alright, let's quickly summarize what we've done today. We've explored 6 different approaches for inserting data using JdbcClient. First, we looked at positional parameters, where we passed values in a specific order. Then, we shifted to named parameters, making our queries cleaner and more readable. Finally, we simplified things even further using bean property SQL parameter source to pass our objects directly, saving us from managing parameters manually. And that's it for today. In the next video, we'll dive into selecting data using JdbcClient.
So stay tuned.
If you found this helpful, don't forget to subscribe, hit the like button, and comment down below how you liked the video. Let me know if you have any questions or suggestions for future videos. See you in the next one.